All right, kiddies, here we go. Last section for Chapter 9. Today what we're going to do is talk about solving quadratic equations again, but now we're going to use something called the quadratic formula. So let's jump right into it. Make sure, before we get going on this lesson, that you have some sort of calculating device with you, whether it be a calculator or sure you can use your phone. Okay, but make sure you have something with you that you can calculate. So let's jump right into this lesson. All right, so again, what we're talking about, we're trying to solve quadratic equations. Again, when we solve equations, our goal is to figure out what is a value of x that makes this equation 0. So we talked about finding zeros or finding roots or finding x-intercepts. Okay, anytime we say those words, basically we're trying to solve. So if I give you this function here of 0 equals x squared plus 5x plus 3, again, I'm trying to find zeros, roots, or the x-intercepts. I'm trying to solve. What do we do? Now, one method we talked about last chapter was being able to factor this. So let's just take a look at factoring. Okay, this one I cannot solve like the last lesson using square roots because I have an x here, right? I have the 5x, so I can't combine like terms. So let's see if we can factor. So again, what we're going to look for is factors here of this case 3. So two numbers that multiply to 3 that add to 5. So factors of 3 are 3 times 1. Those are factors of 3. Now, do they add to 5? No, these two add to 4. So what I'm trying to show you here is that this function right here cannot be factored. So how do we solve this if we factor it, if we can't factor it, if we can't take the square root? Now we showed you in the second lesson here that you could solve this by graphing, but some of you probably saw and what we learned from that is that's kind of a pain in the butt, is to graph these functions and try and figure out what the solutions are. So I'm going to show you another method, and this is by what's called the quadratic formula. Okay, so the quadratic formula is going to make use of our values of a, b, and c. Now, how we actually get this formula, we're not going to worry about that too much. But again, what is a formula? A formula is something that is already solved for us, and all we have to do is plug things in. It's basically what I like to call plug and chug. Okay, so right here, make sure this is on your notes, but make sure you write this down and understand. Okay, given the function ax squared plus bx plus c, all quadratics are of this form. Okay, our goal is to solve for x. Now we talked about that we can't solve for x because we have x squared and x. We can't combine those like terms, so we need another method to do it. So we get this formula for x. This is what's called the quadratic formula. Okay, and what this allows us to solve for is given any quadratic function, this formula is used to solve. And I mean any. We can plug in something, a simple one, something that can be factored. This will end up working. Something that can't be factored, this will work. Something that could be solved using square roots, this would work. This quadratic formula works for any quadratic function. Okay, so what it says is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Holy cow, that looks just crazy and confusing. But again, what three values do you see here? B, a, and c. So all this depends on is what are a, b, and c. So first thing we've got to figure out is what are these values. So taking a look first, what is in our function of x squared plus 5x plus 3, our a value is the number in front of x squared, that's 1, b is 5, c is 3. So I identify those and now I'm set to go. So the quadratic function says I'm going to take x and what I'm going to do is plug it in to each of these terms. So I have negative b plus or minus the square root. So notice we do have a square root there of b squared minus 4ac, so there's a problem inside of there, over 2a. So what I'm going to do is just simply, I want to solve for x, again that's our goal, I'm just going to plug in my value. So I have negative b, well b is 5, so that means negative 5, plus or minus, I'll talk about what the plus or minus means, the square root of b squared, so that's going to be 5 squared minus 4 times a is 1 times c is 3. All that divided by 2a, which is 2 times 1. So all I did is plugged everything in, and now all I have to do is simplify. Plug and chug. Okay, that's what I like to say, plug and chug, you're solving. So how do we go about solving this? Now notice right away we have to think order of operations. Parentheses, exponents, multiplication, division, and adding and subtracting. So when I look at this, what I'm going to solve first is what's inside. Okay, inside the square root symbol, I have 5 squared. So I'm going to do that first. Okay, 5 squared, this is the same thing as 25. And I'm going to subtract from that 4 times 1 times 3. So doing that, 4 times 1 is 4, times 3 is 12. So what that gives me is that's going to be equal to negative 5 plus or minus the square root of 25 minus 12, which is 13. All that divided by 2 times 1, I'm going to write that as 2. Okay, so now, a couple things here. This is what the square root simplified down to the square root of 13. You think about this number, square root of 13 is not a nice number. We did this last section where we plugged this into our calculators, get a decimal. But notice how it's negative 5 plus or minus. Remember that all quadratic equations have 2 solutions. So I want to get 2 solutions. Okay? Write that down. Your goal is to get 2 solutions if possible. Okay? So where do I get 2 solutions from this? Now this is where the plus or minus comes in. And remember that when we take the square root of a number, we said plus or minus that number. So that's basically what we're doing here. Whatever the square root of 13 is, we're going to do plus or minus that. Okay, so what you want to do is take out your calculator, and we're going to try and find out what is the square root of 13. Okay, so if you go ahead and plug that in, you should get this is equal to, sorry, didn't write that down, is about 3.6. Okay, so what this says, it's going to be negative 5 plus or minus 3.6 all over 2. So where do I get my 2 solutions? Here's where. This literally says negative 5 plus 3.6 divided by 2. That's where the plus comes in. Or minus, over here, you have negative 5 minus 3.6 over 2. So the plus or minus, this right here, this little symbol, is going to tell me where I get my 2 solutions from. So it basically turns this one thing into 2 different problems. And now we just go ahead and solve each of these separately. Okay? So plug it into your calculator, it's got negative 5 plus 3.6, and then you're going to take that and divide it by 2, and that should give you, now this is rounded, but you should get an answer of negative 0.7. So that's one of our solutions. And then next, you're going to plug in the second one. You're going to do negative 5 minus 3.6. So notice the difference here. And then you're going to take that and divide it by 2. And here you're going to get negative 4.3. So just making sure we're plugging in a calculator correctly. But notice here I get 2 solutions. Negative 0.7 and negative 4.3. So we're here just using a different formula, plugging and chugging, and just making sure we're calculating things correctly, and we still get our 2 solutions. All right, next examples. I'm going to do one for you, and then I'm going to have you do the second one. I'm going to have you guys do this one, but I'm going to do the first one with you. Okay, so here I have 3x squared plus 5x equals 8. Now, what do we notice about this one that's different? Okay, this one you should see the 8 is on the other side. Now, again, we call all our solutions zeros, roots, or x-intercepts. Remember that we want our equation to equal 0. That's a key thing. So I can't just say my a value is 3, my b is 5, and c is 8. I can't just jump right into it and say that. But instead, I need to rewrite this as 3x squared plus 5x, and then I need to subtract 8 to the other side and set it equal to 0. Now you may think that doesn't make a big deal, but now it's not 8, but instead, let me show this in red, it's negative 8. And that makes a big difference. Okay? So when I plug this in, now I'm going to use my formula. Again, you should have it on your page. I'm just going to jot it down quick. And I'm going to plug things in right away. But I get x equals negative b, which would be negative 5, plus or minus the square root of b squared. Now, I'm going to do this right away. What is b? 5. What's 5 squared is 25. So some of you might like to do that right away. Okay, otherwise it's 5 squared minus 4 times a is 3 times c is negative 8. Okay, and that's where that negative 8 is going to be very important. Divided by 2 times a is 2 times 3. Okay, once you have all that set up, then again what we're going to do is simplify what's underneath the square root first. So you're going to take your calculator, you might need to use that there. All right, you have, notice the right side, you have 4 times 3 times negative 8. And that's going to give you negative 96. So when you do 25 minus negative 96, notice how that gives you, oops, sorry, you're going to get plus or minus radical 121. If you didn't write c as a negative, if you left it as a positive, you would notice that you would get a negative under the square root. Now keep that in mind and think about last section, can you take the square root of a negative? And the answer is no. So if you left it as a positive, that's where you're getting your mistake. But once I have this all set up, then again I can divide by 2 times 3 is 6. Okay, now what's the square root of 121? We can punch that in right away. Okay, so 121, if we take the square root of that, what do you get? And that should be 11. So I'm just going to write that in red off to the side, but that equals 11. So my solution becomes negative 5 plus or minus 11 over 6. Where do I get my two solutions again? That's from the plus or minus. So set up your two solutions. Make sure you write it down just to get the hang of it. Negative 5 plus 11 over 6 and negative 5 minus 11 over 6. And we're going to solve each separately. Okay, so negative 5 plus 11, then you divide by 6. That's going to give you 1. Okay, so I get one of my solutions is 1. And then when I do negative 5 minus 11, divide by 6. Notice here you're going to get negative 16. Divide that by 6. Here you get a decimal, and you get negative 2.7. Okay. Now, again, we couldn't factor this. In this case, we get one whole number, which is nice, 1, and then we get a decimal here, which would have been difficult to get. You actually do get kind of a nice number that we actually could have factored this one, but instead we're using the quadratic formula. All right, I want you guys to pause the video right now and do the third example, 2x squared plus 5x plus 3. Notice when this is equal to 0, so you're all set, ready to go. So give this one a shot, pause it, and go. All right, here you go. There's your solution for the third example. Make sure you check your answer, see what you got. Okay, I found my A, B, and C, 2, 5, and 3. I plugged it in to the quadratic formula. Now notice here I didn't write 5 squared, but I did it right away as 25. Minus 4 times 2 times 3. 4 times 2 is 8 times 3 is 24. So you get 25 minus 24. Let me write that down for you. So this is 25 inside 25 minus 24, which is 1. So that's why I got the square root of 1. Square root of 1 is 1. So I have negative 5 plus or minus 1 is 8. Set up my two separate equations, and I get negative 0.5 and negative 0.75 as my two answers. Okay, so notice here I'm getting two separate answers, solving using the formula. All right, last example here. I'm going to go through this one with you. Now, before we go through this example, I just want to think about, we talked about this last section with the square roots. What causes a quadratic to have no solution? Now, we talked about this as well with graphing. Graphing-wise, we said, remember, the solutions are what we call zeros, or x-intercepts. It's where on the graph they cross the x-axis. So here and here would represent my two solutions. So no solution would represent graphically if my graph didn't cross the x-axis. And remember, square root-wise, if I had the square root of a negative, that was not possible. Both those represented that there's no solution. So let's take a look at the example and keep that in mind. Hint, hint, nudge, nudge. So first thing, what should I do? I have 2x squared plus 11x equals negative 9. What should I do first? Hopefully you said that we take that 9 on the other side and bring that over so that our equation is equal to 0. Hope that you did that. All right, now I'm going to go ahead and solve. So again, what are my A values? A is 2, B is 11, and C is 9. So once you get those values, here you go. I want you to pause quick, and let's plug it into the quadratic formula and see what you get. All right, so plugging things in, you should get negative 11 plus or minus 11 squared, minus 2 times 9, all over 2a. And again, I just showed that 11 squared, I didn't evaluate, and this is 2 times 2, which is 4. Okay, so now simplifying, what we're going to do is simplify the middle. So go ahead and do that. Okay, you should get negative 11 plus or minus square root of 85 over 4. Okay, next step then is you're going to take that 85, find the square root of it. You should find that to be negative, or sorry, not negative, 9.22. Okay, so this one, notice, it's going to work out. Why is this one going to work out? Because notice I have the square root of a positive here. Okay, so I have positive 85, and I get 9.22. Now I'm going to pause here for a second. I want you to finish this problem in just a second, but I want to show you something. Okay, in the quadratic formula, I'm going to write this down. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. keep in mind that in order to have a solution, you need to have some sort of number down here, right? Inside the square root, you need a number. In order to take a square of it, you would say, okay, in this case, it's plus or minus 9.22. But in order to have no solution, there's one thing that cannot be possible, is what if you get the square root of a negative? Right? So this is something I'm going to bring up, and make sure you write this down. This is important. Okay, so what we're going to look at now is this term right here. And that is the square root of b squared minus 4ac. Now this term right here is the most important thing in the quadratic formula. This is known as the discriminant. And let me write that down for you. Make sure you write this down. Discriminant. Sometimes also called the determinant. What does this thing mean? Well, this discriminant tells you about your solutions. Okay? Here's what I mean. If, when you plug numbers in, if you get the square root of a positive, what does that tell you? That means you are going to have two solutions. Okay? I'll put two solu because I ran out of space. If you plug things into these numbers and you get 0, what is that going to tell you? Well, plus or minus 0 is not going to do anything. Right here, negative b plus or minus 0, that's not going to mean anything. So that really means you have your solution is going to be negative b over 2a. Now, we've seen that before, but that means we have one solution. Okay, I'll put 1s, one solution. And lastly, if I have, and I calculate that, and I put in my numbers, and I get negative underneath the radical sign, what does that mean? I have 0 solutions. Okay? So this discriminant right here, this term, tells you how many solutions you have. So I could give you a function, and I could have you calculate this right away, and you could tell me how many solutions this function is going to have, whether it's going to have 2, 1, or no solutions based off of this discriminant. Okay? Now you can go ahead and finish this problem, but I'm going to stop there, okay? Hopefully this video made sense to you. A lot of plug and chug. It's a lot of fun, right? And again, it works for everything. So this is now something we can use from here on out if we really want to. Okay? Hope you enjoyed. We'll see you in class. Good luck on the practice problems, and peace. I'm out of here.